Welcome to qnawire.
Okay, so this is the force diagram for this question. Since the spool wire is in equilibrium, therefore the net force along the xy direction should be 0. And we also know that the wall at point A is smooth, therefore there's no friction at point A. So now let's take a look. So we know the net force along the x direction should be 0, which is equal to P minus FB plus NA. And this will give us P is equal to NA plus FB. And the net force along the y direction should be equal to 0 as well. So we have NB minus W is equal to 0. So NB is equal to W. NB here is the normal force at point B. W here is the gravity of the spool. And we know NA here is the normal force at point A. We're looking for to determine FB here is the friction at point B. So now let's take moments about point B. Consider counterclockwise moment is positive, clockwise moment is negative, and this will give us such equation here. So eventually you'll have the NA is equal to 2P over 3, which is equal to 2 times 300 pound over 3, and this is equal to 200 pound. Since we know the force P is given as 300 pound. So we also know that force P can be equal to NA plus FB. Therefore, FB can be equal to P minus NA, which is equal to 100 pound. So in order to prove that normal force at point A is 200 pound, we need to make sure that the friction at point B is less than the maximum friction. So the maximum friction at point B can be equal to the coefficient of the static friction times NB. And this can be also equal to mu SW, since W is equal to NB. If we plug in values, we'll have 0.35 times 300 pound is equal to 105 pound. As you can tell, the friction at point B is less than the maximum friction. Therefore, the spool of wire is at rest, which means that the normal force at point A should be equal to 200 pound. And this is the answer for this question.